9.3. Recall, remember, pi is defined as ratio. Pi is defined as ratio of circumference of the circle, and here we suppose that circumference is c of a circle to its diameter. Diameter is represented by d. So symbolically we can say that pi is equal to c upon d. This seems to be contradict. So pi is c upon d, that can be expressed in the form of p upon q. So you will think that it is a rational. So we will say that this seems to be contradict, opposite the fact that pi is irrational. You know that pi is irrational. In earlier sum I told you that pi is an irrational. How will you resolve this contradiction? So how you will reply that pi is irrational, not a rational? For that you know that there is no contradiction, there is no opposite things. Remember that when you measure the length with a scale or any other device, you only get an approximate rational value. When we measure the certain things with the help of scale, we are getting approximate value, not exact. So you may not realize that either C or D is rational. So approximate value is there, so we can't say that it is a rational. So there is no contradiction in the given statement. Question 4. Represent root 9.3 on the number line. So here we will study how to represent any decimal form on the number line. For that you have to draw any one line. Draw one line. Name the initial point A and point B of the distance whatever is given. You have to write AB is equal to 9.3 units, as you have to find root 9.3. So AB is equal to 9.3. Then take a point C on the number line such that BC equal to 1 unit. Take BC is equal to 1 unit. Then find out the midpoint O of AC. Find out the midpoint O of the line segment AC by drawing the perpendicular bisector. Now draw one semicircle. Draw one semicircle with center O. Draw semicircle with center O and radius is equal to OC or OA. You can put your compass on O. Put your compass on O and pencil on A or C. Your pencil should touch to A or C. Then with the center O, draw one semicircle. After drawing semicircle, draw one perpendicular. Draw a line perpendicular to AC through B. So from B, you have to draw one line perpendicular to AC with the help of protractor or set square. You have to draw one line perpendicular at B with the help of protractor or set square. And let that line intersect the semicircle at D. This perpendicular line from B intersect the semicircle at D. So this BD will represent root 9.3. So BD is equal to root 9.3. If you want that number on number line, then again with the help of compass, put the pointer of the compass on B and pencil on D, and let the compass come and intersect the line at E. So this will represent root 9.3. So like in this way, you can represent any root of any decimal number in this way on the number line. Question 5. Rationalize the denominator of the following. Rationalize means you have to remove root from the denominator. If there is a root in denominator, by doing any operation you have to remove it. Here it is 1 upon root 7. So you have to multiply, here we want to remove this root 7. To remove root 7 you have to multiply it by root 7. Now if you multiply the denominator by root 7, to keep it equal value, you have to multiply also numerator by root 7. So root 7 upon root 7 means 1. So you have multiplied the given number by 1. So root 7 into 1 means root 7. Root 7 into root 7 will give you 7. So answer is root 7 upon 7. So here you can see that we have removed root from the denominator. Now second question. 1 upon root 7 minus root 6. So here you have to multiply it by root 7 plus root 6 upon root 7 plus roots opposite number. If here it is minus, here you have to write plus. If here it is plus, you have to write minus. But numerator and denominator must be same because this gives you 1. Root 7 plus root 6 upon root 7 plus root 6 gives you 1. So you have not make any change in the given number. Multiply numerator and denominator. So numerator will be root 7 plus root 6. Here root 7 minus root 6 into root 7 plus root 6. So this becomes of the form a plus b, a minus b. So you know the formula a square minus b square. So root 7 plus root 6 upon root 7 square minus root 6 square. So root 7 plus root 6 upon square of root 7. Square of root 7 is 7 and square of root 6 is 6. So 7 minus 6 equal to 1. So answer will be root 7 plus root 6. So here we have removed the root from the denominator. So now you can see that there is no root in the denominator. 3. 1 upon root 5 plus root 2. So if we want to rationalize the denominator, you have to multiply by root 5 minus root 2 upon root 5 minus root 2. So these both are same, this give you 1. So we have multiplied this by 1. Multiplied numerator and denominator. So root 5 minus root 2 upon root 5 plus root 2 into root 5 minus root 2. Again it is of the form a plus b, a minus b. So a square minus b square. Numerator remain as it is. So here you will get root 5 square minus root 2 square. Numerator as it is, square of root 5 is 5 and square of root 2 is 2. So you will get root 5 minus root 2 upon 5 minus 2 equal to 3. So this will be the answer. Here we have rationalized the denominator. Now you can see that there is no root in denominator and value of both is same. Similarly, question 4. 1 upon root 7 minus 2. 1 upon root 7 minus 2. So you have to multiply it by the opposite surds. That is root 7 plus 2, root 7 plus 2. Here it is minus. So you have to multiply by plus. This is 1. So keep the numerator as it is. Root 7 plus root 2 as it is. And here root 7 minus 2, root 7 plus 2. Again it is of the form a plus b, a minus b. So you will get a square minus b square. That is root 7 square minus 2 square. Numerator remains as it is. Root 7 square gives you 7 and 2 square gives you 4. Root 7 plus 2 upon 7 minus 4 is equal to 3. So rationalized form of 1 upon root 7 minus 2 is root 7 plus 2 upon 3, and here there is no root in the denominator. So this will be our required answer. So exercise 1.5 is over. So now we have to start exercise 1.6. But before starting exercise 1.6, you have to learn some laws which you have already studied in standard 8. Laws of exponents, or it is also called indices. for the real number. So first I will teach you laws of indices. Here we will take three numbers a, m and n. Here they are natural number. A is called base and m and n are called exponents. So first rule is that a raised to m into a raised to n is equal to a raised to m plus n. Means if the base is the same, their indices are added. As for example, if you take 2 raised to 3 into 2 raised to 4, 2 raised to 3 into 2 raised to 4, you can see the base is the same. So you have to write the base only once. That is 2 raised to 3 plus 4. That gives you 2 raised to 7. So if the base is the same, their indices are added. Now rule number 2. A raised to m whole raised to n. A raised to m whole raised to n gives you a raised to m into n. As for example, 3 raised to 2 whole raised to 3. 3 raised to 2 whole raised to 3. So this gives you 3 raised to 3 raised to 2 whole raised to 6 gives you 3 raised to 6. 2 3s are 6. Means a raised to m whole raised to n, m into n. But if it is without bracket, if it is like this, 3 raised to 2 whole raised to 3. So here you cannot do 2 3s are. This is cube of 2. So here you will get 3 raised to 8. That is cube of 2. See the difference. If there is bracket, 2 3s are 6. If there is no bracket, then you have to do cube. 2 raised to 3 means 8. So 3 raised to 2 raised to 3 gives 3 raised to 8. See the difference between these two. Now third rule. A raised to m divided by a raised to n. So there will be three possibilities. So if m is greater than n, then a raised to m upon a raised to n gives you a raised to m minus n. Like this, 2 raised to 5 upon 2 raised to 3. So here you can see that 5 is greater than 3. So this 3 will go in numerator. It becomes 2 raised to 5 minus 3. This gives you 2 raised to 2. 3 will go towards 5. 5 minus 3 gives you 2. Now if the denominator n is greater than if n is greater than n, so a raised to m, so m will come in denominator. It's like this, 2 raised to 3 upon 2 raised to 7. So here you can see that n is greater than m. So this will become like this, 2 raised to 7 minus 3, that is 1 upon 2 raised to 4. So this m will come in denominator if n is greater than m. Now third situation, if m and n both are equal, if m and n both are equal, so you will get 1, because 2 raised to 3 upon 2 raised to 3, it will cancel and you will get 1. So if m and n are equal, the answer will be 1. Now if there is a product of two numbers, and if the power is the same, you can write the common power. A raised to m, b raised to m is equal to a b raised to m. If it is like this, 2 raised to 3, 3 raised to 3, so you can write 2 into 3 whole raised to 3, that is 6 raised to 3. m m will be common. A raised to m, b raised to m gives you a b raised to n. Now any number raised to 0, any number raised to 0 always gives 1. Any number raised to 0 always gives 1. Now if you have root of any number, that is root n of a, so it will become exponent a raised to 1 upon 9. If it is cube root of 2, so this can be written as 2 raised to 1 upon 3. Now if you bring the power from denominator to numerator, its sign will be changed. 1 upon a raised to n, if you write in numerator, it will be a raised to minus n. Means if it is 1 upon 2 raised to 3, it can be written as 2 raised to minus 3. So when you bring that in numerator, its sign will be changed. Now we will start exercise 1.6. First question is simplify. If it is given 64 raised to 1 upon 2, so you know that 64 can be expressed in the form of 8 raised to 2. 8 raised to 2 is equal to 64. You have to express the number in whose power is 2, because here you have 2. Whatever number is here, you have to bring it here. So 8 square whole raised to 1 upon 2. So here 2 will cancel. You will get 8 raised to 1, that is 8. Similarly, 32 raised to 1 upon 5. So 32 can be written in the form of 2 raised to 5. If you will multiply 2 5 times, 2 into 2 into 2 into 2 into 2, 5 times, you will get 32. So 2 raised to 5 raised to 1 upon 5. Again 5 will cancel. 2 raised to 1, that is 2. So 32 raised to 1 upon 5 gives you 2. Question number 3. 125 raised to 1 upon 3. So 125 can be written in the form of 5 raised to 3. You have to always write the number here, which is here. If it is 1 upon 3, you have to write something raised to 3. If here it is 5, then you have to write something raised to 5. So 5 raised to 3 gives you 125. Again 3 will cancel. 5 raised to 1 gives you 5. So 125 raised to 1 upon 3 gives you 5. Question 2. First one, 9 raised to 3 upon 2. So you have to express 9 such that whose power is 2. Because here the denominator is 2. So you have to write in the form of 3 raised to 2. So 2 will cancel. 2 will cancel, gives you 3 raised to 3. And 3 raised to 3 means 27. So 9 raised to 3 upon 2 equal to 27. Second, 32 raised to 2 upon 5. So you have to express 35 something raised to 5. Express 32 in the form of something raised to 5. So 2 raised to 5 gives you 32. Again 5 will cancel. You will get 2 raised to 2. 2 raised to 2, that is 4. So 32 raised to 2 upon 5 gives you 4. 16 raised to 3 upon 4. So express 16 in the form of something raised to 4, because here there is 4. So 2 raised to 4 raised to 3 upon 4. 2 upon 4 gives you 16. So 4 will cancel. 2 raised to 3 gives you 8. So 16 raised to 3 upon 4 is equal to 8. Fourth one, 125 raised to minus 1 upon 3. Express 125 in the form of something raised to 3, because here there is 3. So you have to express 125 in form something raised to 3, that is 5 raised to 3. 5 raised to 3 gives you 125. 3 will cancel, gives you 5 raised to minus 1. You can write 5 raised to minus 1, or as the power is minus 1, you can take it in the denominator. So that will comes to 1 upon 5. 5 raised to minus 1 and 1 upon 5 is the same. Now question 3. 2 raised to 2 upon 3 multiplied by 2 raised to 1 upon 5. So here you can see that base are same. Base of both the number is same. So you have to write only once. So you will write 2 only once and add the exponents. You have to add this power. That is 2 upon 3 plus 1 upon 5. 2 upon 3 plus 1 upon 5. Now here there are different denominators, 3 and 5. So you have to take LCM. So LCM of 3 and 5 will be 15. So here you will get 3. 5 2s are 10 and 5 3s are 15. So 10 plus 3 gives you 13 upon 15. So 2 raised to 2 upon 3 multiplied by 2 raised to 1 upon 5 gives 2 raised to 13 upon 15. Means you have to add the indices. Question 2. 1 upon 3 raised to 3 whole raised to 7. So you have to give this 7 to both numerator as well as to denominator. So 7 is given to 1 as well as 3 raised to 3. So 1 raised to 7 upon 3 raised to 3 raised to 7. 1 raised to any number. 1 raised to any number gives you 1. 3 sevens are 21. 3 into 7. 3 sevens are 21. So 1 raised to 7 gives you 1 upon 3 raised to 21. So 1 upon 3 raised to 21. If you want to bring in numerator, this 21 when comes in numerator becomes minus. So 1 upon 3 raised to 21 can also be written as 3 raised to minus 21. 3 raised to minus 21. Third question. 11 raised to 1 upon 2. 11 raised to 1 upon 4. So here both the number are same. Means base is same. 1 upon 2 is greater than 1 upon 4. 1 upon 2 is greater than 1 upon 4. So you will bring this 1 upon 4 in numerator. So 1 upon 2 minus 1 upon 4. Again you have different denominators. So you have to take LCM. So LCM of 2 and 4 will be 4. So 2 into 2 gives you 4. So 2 ones are 2, 1 as it is. 2 minus 1, that is 1. 11 raised to 1 upon 4. 11 raised to 1 upon 2 divided by 11 raised to 1 upon 4 gives you 11 raised to 1 upon 4. Fourth one. 7 raised to 1 upon 2 into 8 raised to 1 upon 2. Here you can see that both the power are same. So you have to take it out common. So 7 into 8 whole raised to 1 upon 2. 7 into 8 whole raised to 1 upon 2. You know the 7 8s are 56. 56 raised to 1 upon 2. So 7 raised to 1 upon 2 into 8 raised to 1 upon 2 gives you 56 raised to 1 upon 2. So here this exercise 1.6 is over and even the whole chapter is also over. So here the chapter number 1 is over. So next time we will come and see chapter number 2.